Okay, so in our last part of the lesson, we looked at graphing absolute value functions, and we started to see some of the patterns that happened. Now we're going to graph some more with these changes or these transformations, and we're going to see if we can figure out what the patterns are between the changes in the equation and the changes we should expect to see in the graph. So starting with our parent function, remember the parent function for the absolute value was the shape that looked like this. It started at the origin and it went off 45 degrees to the right and 45 degrees to the left. That was our parent shape. So when we graph it on here, let's do our chart, we're going to look to see how is this equation different than that parent shape. So here's our x, and this will be the y. We'll go ahead and we'll use same numbers here, -2, -1, 0, 1, and 2. So absolute value of -2 minus 4 changes to a positive, this, so -2. And this one will just be 0, minus 4, -4. And 1 minus 4 will be -3. 2 minus 4 will be another -2. So if we plot these points on here, -2, -2, -1, -3, 0, -4, 1, -3, and 2, -2. So there's our graph. And again, think about how is that different than this parent function that we saw. The parent function was up here. It looks like the blue one has shifted down 4 units. So that's the change that we see. Let's look at this one. This one actually has already been graphed for us, okay? And we see the change in here. This is a 1/2. So if you were to imagine having done a table for this one, your x's and your y's, and again, -2, -1, 0, 1, and 2. 1/2 times a 2 would be 1. 1/2 times a 1 would be 1/2. 1/2 times a 0 would be 0. 1/2 again, and a 1. Let's check, make sure those dots are correct. Here's the 0, 0, 1, 1/2, 2, 1, -2, 1, -1, 1/2. Yep, there it is. But that's not the parent function. The parent function went 45 degrees out and 45 degrees out. So this one, we could say, looks like it's a little flatter. So stretched, flatter. It hasn't been moved because the center is still on the origin. That's still the same, but it's been squashed, if you will. And if we look at our next one here, I'm going to go ahead and I'm going to graph the parent function because we know what that parent function should look like. It should look like this. So how is this one going to look different? We do our chart and we take a look, and maybe you're already starting to see the patterns in here. -2 and this give us -1, which is +1. -1 and 1 will be 0, 1, 2, and 3. So -2, 1, -1, 0, 0, 1, 1, 2, 2, 3. So this one, okay, this one doesn't look any flatter, but he's definitely been moved. He's been shifted left. That's what's happened to him. So maybe you're starting to see some of the patterns here. When it's on the outside, like the -4, that moved it down 4 units. When it was on the inside here, the 1, that moved it left 1 unit. And if you think back to what we saw in our last lesson here, let me just move this up, let's take a look. In our last lesson, we looked at a bunch of 3s, right? We saw a 3 on the inside, or excuse me, a 3 on the outside, and that moved it up 3 units. And then when we looked at the 3 on the inside of the equation here, so just scrolling down just a bit, 3 was on the inside, that moved it left 3 units. So one of the things that we start to see is that the inside and the outside make a difference. If you have something on the outside, that's going to be the up-downness, or some people have said the outside numbers move it along the y-axis, whereas the inside numbers move it along the x-axis. So this one here, the one right beneath it, this one's another inside one, but it's the opposite sign as before. So instead of moving it, this one moved it, it was a plus, it moved it to the left. This one's a minus. We should expect this one to shift us to the right. And sure enough, if you look at your graph here, this little starting point is moved over. Remember, the parent function always starts at the 0, 0 for the absolute value. And that one's been shifted right. And we didn't even have to do a table to do that. We want to start looking at the patterns of the numbers inside and outside. Here's one, at the bottom of this page. Let's see if we can think about the pattern for this one. This one has a number on the inside, and this number on the inside is the -3. It also has a number on the outside, which is a +2. So, the -3, that's similar to the -1. -1 moved us right 1 unit. So for us, the -3 should shift us right 3 units. And sure enough, look at this, 1, 2, 3 units over. And the 2 on the outside, okay, if you look back at the other examples we've done, a +2 moves it up 2 units. So shifted right 3 units and up 2 units. So when we talk about the patterns, remember we said that there were 4 types of changes that you could see. There's vertical, which is up or down. There's horizontal, which is side to side. There's stretch, which we'll talk about in just a second. And then there's reflections at the bottom of this page. Remember that when you see something on the outside of an equation, that's going to move you up or down. This one here means that you will move up k units, whatever k is. And this one, the negative, means that you will move down k units. Horizontal, we got to be careful. Horizontal is a little tricky. Normally you would think that the plus would mean that you're moving to the right, but it's actually the reverse for horizontal. This means we're moving left h units, and the negative means that we're moving right h units. So please watch out for that. This one is always a tricky one for us. And in terms of stretch, stretches are letters or numbers that come right before whatever we're talking about in here. I'll highlight that right there. If it's a regular number, like say a 3, 4, 5, whatever, it will make it tall and narrow. It'll look like a tall and narrow graph. If it's a fraction, a 1/3, a 1/4, a 1/2, a 1/10, it will stretch it flat. Okay, it'll flatten it out. And then lastly, when we talk about reflections, these ones are a little different for absolute value. The only reflection you've seen so far is when you see the reflection on the outside. There are reflections that do happen on the inside, okay? But with an absolute value, it's a little different. These ones, this will reflect over the x-axis, and this one will reflect across the y-axis. Okay. So if we're going to talk about some examples, what would these look like for these different types here? For this one, let's talk about vertical. For a vertical, if we had y equals absolute value of x plus 5, that means that instead of starting at the origin, we would go up 1, 2, 3, 4, 5, and then draw our graph. If we were going to do y equals absolute value of x minus 3, that means that we would go down 1, 2, 3, and then draw the same shape. So it's really quick. Notice I didn't have to do a table. I just followed my patterns for these. Let's look at the same thing for horizontal. So for horizontal, remember these ones are weird. They're not what you expect. Y equals absolute value of x plus 2 means that I'm actually moving to the left 2 units. So moving 1, 2 over, and then I put in this guy here. Or if I have y equals absolute value of x minus 5, 1, 2, 3, 4, 5 units to the right, and then we draw in the absolute value. Again, didn't have to use a table, just using our patterns that we're recognizing. And we know the shape. The shape is the high V shape. For stretches here, let's say you have y equals 3 times the absolute value of x. This one, it helps to think about it. Think about your shape. It normally starts at 0, 0. Normally it's 1, 1, right? But since it's a 3, it's going to become 1, 3. So 1, 2, 3 here. Normally it's 2, 2. But the 2 times a 3 makes a 6. So 4, 5, 6. So 2, 6. So this side and this side will be steep. Steep and narrow. We said, however, that if you have a fraction, it makes it flat. So think about like y equals 1/2 absolute value. You're still starting at 0, 0, but instead of being at 1, 1, you're now at 1, 1/2. Instead of being at 2, 2, you're now at 2, 1. So this one looks like someone sat on it. That's what we mean by stretches. And then lastly, for our reflections, like we said, these ones are a little different. If you have y equals negative absolute value of x on the outside, that's across the x-axis. So again, here's normally our parent function, right? Across the x-axis means that we're focused on mirror imaging across this line. So their answer will actually mirror down here and mirror down here. So this line, this dotted line here, becomes solid, and this dotted line flips over on this side. When you have y equals absolute value of negative x, so it's on the inside, here's your parent function, right? The dot, 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 dot. But this time, we're reflecting across the y-axis. So this dotted line here on this side becomes nice and thick over here, and the dotted line on this side becomes nice and thick over here. So it actually ends up being the same shape. You can't tell the difference looking at it. Other shapes we talk about, you will see a difference in how it flips. But those are your 4 types: reflections, stretches, horizontal, and verticals.